Hey everyone, my name is Amog and I'm a software engineer here at Anyscale. If you've ever run into problems with building LLM applications and in particular being able to effectively and quickly embed large amounts of documents, in this talk we'll go over how you can use Array to easily parallelize this across multiple GPUs, showing how you can embed thousands of PDF documents in a matter of minutes. This talk is the second part in our series of LangChain and Array, showing how you can use both together to build LLM-based applications. In our first video, Wally showed how you can use LangChain and Array together to build a search engine on the Array documentation. So if you recall, there's two steps to building this type of application. The first is that you want to generate embeddings for a document corpus that you have and that you want your large language model to extract information out of. So you generate these embeddings for these documents and store it into a vector store. This happens in an offline phase. Then the second step is an online phase where you actually deploy your application that can accept incoming your user queries, such as questions about your documents. That user query is also embedded, and that embedding is used to pull similar documents from the vector store, and both the user query and the similar documents are passed as prompts into the large language model so the LLM can extract any relevant information that you have. In this particular video, we're going to be focusing on step one specifically. How can we effectively, quickly, and easily generate embeddings from a large set of documents? Now let's dive into what the flow for this particular step looks like. First, we have 2,000 PDF documents stored in S3, or for our case, these are documents that have been loaded from archive. Then you want to load those files as bytes and convert those bytes into a string text. Then you want to split those text into chunks, and each of these chunks are what's going to be converted into an embedding. And finally, we take a pre-trained embedding model, for example, like a sentence transformer model, which will take those chunks and encode it into a vector, such that similar pieces of text also have similar vector representations. Finally, once we have embeddings of all 30,000 pages, we can store them into a vector database. So this all happens as an offline phase, and like we talked about during the online phase, a user query is used to pull similar documents from this vector database to be passed as context into a large language model. So overall, like LangChain really makes this process very easy and has all the abstractions, the integrations needed to quickly get started with this type of development. However, the problem is that when you have a large document corpus, in our case, like 2,000 PDFs and like tens of thousands of pages across all of these documents, this can take quite a long time if you're not parallelizing, right? And especially if you want to develop very quickly, try out different embedding models, try out different chunk sizes, try out different documents itself. You want to be able to do this process in just a few minutes, right? So you can try out all these different approaches rather than doing them all in like a matter of hours. So this is where Array comes in. By using Array, and in particular the Array datasets library, we can parallelize this whole process across many GPUs. So what would normally take roughly like an hour to do for 2,000 PDFs, we can do it in a matter of minutes. Now let's take a look at what the actual code looks like to see how we can use Array datasets to parallelize this whole process very easily. So what I'm showing here is the Anyscale platform, which is a managed version of Array. Everything you see here can be done fully in open source using the Array open source cluster launcher, which we go over in the blog post. But for convenience here, I'm going to be using Anyscale platform. And you see I have a cluster consisting of 5 nodes and overall 20 GPUs in this cluster. So first thing I'm going to do is I'm going to run this Python script, which will generate the embeddings for us. So I'll have this running in the background, and then let's jump into what the actual code looks like. So as you can see, the code here overall is roughly 100, just a little over 100 lines. So even though we have like a very simple piece of code here, we can effectively parallelize across all of our GPUs. So let's go through each of the steps. The first thing we have is that we have our S3 bucket containing the documents, the PDF documents that we want to embed. And we can use Array data APIs to read those in as an Array dataset. So we just call read binary files, and we have an Array dataset here. Now that we have this dataset, we can apply the transformations that we talked about on this dataset. So take those bytes, convert into text, take the text and split them into chunks, and then take those chunks and use an embedding model to encode them into vectors. So the first transformation we want to do is to take the bytes and convert them into text. So we define a function to do that. The function takes in the bytes, like a bytes object, and then we can use a PDF reader library, which is the same library that LangChain uses to extract the text for each page in our PDF doc. Once we have defined this function, we can map this across every single item in our data set to transform the data set. Array datasets are lazy by default, so these transformations are not applied until we trigger the entire execution at the end. Now that we've converted our bytes into text, the next step is to split the text into chunks. So again, we define a function. This time, this function takes in a string for the text for each page, and we use LangChain's text splitter abstraction, passing in a chunk size of 1,000 to convert each page of text into chunks. So we can apply this transformation again on our data set, and then now we have a data set containing chunks. So after these two transformations, we went from 2,000 PDF documents to 30,000 pages to now roughly 150,000 chunks. Each chunk is 1,000 characters across our entire document corpus. Now that we have our chunks, the final step, the final transformation we want to apply is to actually use an embedding model to encode each of these chunks into a vector. So here we do a similar thing. We define a transformation, but instead of defining a function, we define a class. And in particular, we define an embedding class. So the reason we do this is because initializing a transformer model can be pretty expensive. So you only want to initialize it once per GPU and reuse that same model for multiple batches rather than having to initialize the same transformer model for every single batch. So in our class, we initialize our sentence transformer model using the same default model, pre-trained model that LangChain uses. And then for each batch of data, for each chunk, we can use this transformer model to encode the chunk into a vector. And then we can return both the original chunk as well as the embedding for that chunk. And again, we can map this on across our data set. So apply this transformation. In this case, we want to specify to use GPUs. And we also want to specify a batch size. So we want to use the largest batch that can fit onto a single GPU to maximize our GPU utilization. So now we've defined our three transformations. What we can do now is iterate through the results of this data set. So this will actually trigger execution of the entire pipeline that we've defined. And once we have the outputs, here we can then store these into a vector database, same way you would do it with LangChain normally. So we define like a FICE vector database, store our embeddings, and then we can save this vector database locally. So let's take a look at the progress of the script. And you can see this is almost done. So it's created the vector index, we've saved it locally. And overall, this is going to take a little bit less than 4 minutes to finish. So just under 4 minutes here. So in just 4 minutes, we've embedded 2,000 PDF documents. And we can also take a look at the RAID dashboard, which can show us information about our GPU utilization. So here, as you can see, during this time the computation is actually happening, our GPUs are nearly 100% utilized. So all 20 GPUs. So we saw that you can just 100 lines of code using the RAID data APIs, we can parallelize this embedding generation process across 20 different GPUs. So just to recap what we talked about, using LangChain makes it very easy to generate embeddings from PDF documents. But in order to develop and move quickly, especially with large amounts of data, you need a way to scale this out and to parallelize it effectively. And that's what we're doing with Array. So overall, with Array and LangChain together, we can index 30,000 pages in 4 minutes. So hope you enjoyed this talk. We'll have more upcoming videos about how you can use LangChain and Array together to build LLM applications that can be used in production and for larger scale.